Hello everyone, and welcome to today's chem lesson. Today we're going to wrap up our unit on bonding by looking at the third and final type, metallic bonding. We've spoken already about covalent bonding, which is between a nonmetal and another nonmetal. We've spoken about ionic bonding, which is between a metal and a nonmetal. And that leaves metallic bonding as the last combination we can talk about, a metal and itself, or a metal and another metal. Metallic bonding is a little bit different than ionic and covalent, and it leads to some really interesting properties. The electrons are not really shared or transferred between the metal atoms, and instead they're this weird hybrid where they are pooled together to create a universal sea of electrons. And we're going to get into that in a little bit more detail with the picture in a little bit. If we want to draw a metallic bond, first we start by looking at the nuclei of the metal atoms. And in this case, I'm just going to draw these 9. We'll use these as our starting point. Now imagine this comes out of the page towards you and deeper into the screen away from you, right, in a 3-dimensional shape where we have atoms stacked on top of each other. This central nucleus cannot move in any direction without being repelled by another positive nucleus, right? Any direction you try to take this nucleus, there's another positive in the way that will keep it in its place. So they're stuck in this grid-like pattern. The electrons, like I said before, they're pooled together. So there's no firm bonds that say, 2 electrons shared between this one and this one. Instead, the electrons have free reign and can kind of move wherever they want, wherever they're needed, around the nuclei of these atoms. And that leads for some really neat properties. Right? This is what allows metals to change shape, become wires, and be good conductors of electricity. Right? Let's look at this in a little bit more detail. Let's get a clearer picture up. If I draw a little bit bigger this time, let's go 4 and 1, 3, 4, 5, 6, 7. All right, let's fill this in. If this is the picture I'm going to be looking at, right, if this is a metallic substance with metallic bonding, none of these positive nuclei can move because they're locked into place by the atoms on either side of them, right? I'm putting these dots. We're going to keep going in every direction. We're going to keep going, stacking on top, coming out of the page towards us. We're going to stack going back into the page behind us. Right, this is going to continue in every direction. We're just looking at a small piece of it. Right, nuclei are held in place. The electrons, which again I'm going to make green, are pooled together to form a universal, accessible sea of electrons. And they go wherever they want. They meander around, and they get to belong to every one of these nuclei, and yet also to none of these nuclei. Right, we can just kind of draw this pattern moving wherever we want. But eventually we are going to go near each of these positive nuclei. Right, this phenomenon, this fact that the electrons can go wherever they want, is referred to by other chemists as the sea of electrons. They can move where they want, they can ebb and flow, depending on what situation you put things in. Right, and this allows for metals to do the things that metals do. If I decide to come at this piece of metal with a hammer, and I want to come right down on top of this atom here, we are gonna see some movement, right? And I'm gonna have to erase my electrons. But if I come down on that one atom with the hammer, I am going to end up pushing all of them with enough force to be shifted downwards. Now, instead of the substance breaking, right, let's just put some electrons back in here. Instead of the substance breaking, instead what we have is a dent being formed. Right? Instead of it shattering into pieces, I just dented my piece of metal. Right? The fact that there are no firm bonds, right, like we have in a covalent substance, means that there's nothing that can really break. So if I hit this with a hammer, the H will break off, and we'll end up with this bond being broken and shattered. If you hit an ionic substance with a hammer, you get the same thing. You get a shattering happening. But for a metal, because these things are kind of in a magnetic suspension, if you hit it with a hammer, you're going to shift some of it downwards. You're going to move it a little bit, but you're not going to break anything. This still works. This is also the reason why metals conduct electricity. Right, if we come back to our starting point here, metals conduct electricity because of the fact that the electrons can go wherever they want. Again, let's just put some electrons in here. Right, they can go wherever they want in this substance. If I take a wire and I connect it to this piece of metal, the electrons that are in the wire can take whatever path they choose to get to the other side of the wire and continue their path, right? They can go through without a problem because those electrons are free flowing. In an ionic bond or a covalent bond, there's no room, there's no path for electrons to take. They are very defined in where they are. Right? If I tried this with a covalent bond, there's no room for extra electrons to make their way across this substance. Hydrogen is happy with 2 electrons. Carbon is happy with 8 electrons. It doesn't want any more. It can't really facilitate the moving of electrons across from one H to the other. If I try to connect this through a wire, same thing with an ionic bond, right? There's no room for those electrons to exist. But metals, they have all the room. They've got this sea of electrons. You can have more electrons come through. That's no problem. In physics, you're going to talk about why metals make good magnets, and it's for this reason as well, right? The sea of electrons helps create magnetizable objects. But this is not a physics class. Here we're just for chem. And with that, that's all I've got to say about metallic bonding. And so I'm going to ask that everybody make their way over to the Google Meet for questions, comments, concerns, and attendance. And I will see you there.